Hello, this is how to enable Hibernate Suspend to Disk on Ubuntu 26.04 operating system. This is a fresh installation. The computer is a laptop, has UEFI, is recent, and the UEFI doesn't have secure boot enabled. On Google, I searched Arch Wiki Hibernate. I got to this page from the Arch Linux Wiki. As a recapitulation, there's suspend to RAM, which is also called suspend, and then we're after hibernate, which is suspend to disk. For this, we're going to need swap space. This installation of Ubuntu 26.04 comes with the slash partition formatted as ext4, and there's a swap file. So we want to increase the size of the swap file to be larger than the available random access memory size, which is 32 gigabyte, which means that we will create a swap file that's 34 gigabytes in size. Reading through the Arch Wiki page, we can see that we will need swap space, and we will use systemd for hibernation. We should already be able to suspend, which is suspend to random access memory using systemd. Let's actually try this first, and we'll make a cycle of suspending to random access memory and then restoring to see if this hardware behaves correctly, at least when suspending to random access memory. So the command line is systemctl, and then the verb is suspend. So we're at this part of the page where it says that systemctl suspend should work out of the box. So we managed to successfully suspend to random access memory. Suspension was instantaneous, restore was also instantaneous. While the computer was suspended, the LED on the power button was blinking to signify that we did not shut down or hibernate the entire computer, so the computer is not consuming power. Instead, the computer is consuming power for keeping the random access memory running and containing the ongoing suspend to random access memory image. Next up, so we demonstrated that systemctl suspend works. We want to have systemctl hibernate work. Let's see how we do that. So we need a swap partition or file. We cannot use multiple space partitions or files, just one. There needs to be enough room to write the contents of the random access memory there. There is all sorts of knowledge required if you want your random access memory to be larger than your swap space, which is your swap partition or your swap file. We're not going to go there. We'll just make sure that the swap file is indeed larger than the size of the random access memory. Okay, and then what we want to do is hopefully the init ramfs systemd etc is configured correctly such that hibernation should work. The thing that we want to do is to make sure that this feature works correctly out of the box. We're using a UEFI system, and when we use systemctl to hibernate the computer, the systemd will find the correct place where to store the image of the random access memory. We'll use the correct swap file, it will also write inside the UEFI variable named hibernate location, hopefully the partition where the file is and the offset at which position ext4 file system that swap file starts. So it says, in theory, we should not edit the kernel command line parameter to specify the resume device and the resume offset. We'll see if that's the case. So theoretically, the only thing that we need to do is to just increase the swap size. Let's do that. Says swap on show to see the size of current swap locations. There's just one swap file, name slash swap file, 0.5 gigabyte in size. Okay, and we want to create a swap file. We're using the ext4 file system. Let's remove the swap file from the disk entirely. So that's swap off. And then what? Free should show no swap sizes, which it does. Next up, we're going to allocate $34 gigabytes in size, a file. Okay, next up, again, let's check random access memory size 32 gigabytes, the slash swap file 34 gigabytes. We should probably fix this error to set permissions on slash swap file. If I remember correctly, you needed to set the to run change mode command line on the slash swap file. I cannot see anything in here mentioned, so hopefully it just works. We're going to run the command line free again, and it's not what we want. We forgot to delete the file. So swap off, and then remove the file. And then we're going to create it again. And we're going to enable it, swap on. We're going to run free to see if the swap has been enabled correctly. And this is what we wanted, 34 gigabytes in size for the swap file and random access memory 32 gigabytes. We need to make sure that after we reboot the computer, the swap will be enabled again. Hopefully, the configuration of the system, either through /etc/fstab or some other method, has used the same name for the file, for the swap file, which is /swap file. So nothing needs to be done because we've created another swap file with the exact same name, /swap file. So that should be it for editing the swap file size. We don't need to reload. anything. Next up is the moment where we test hibernation. Hopefully it just works. The command line is systemctl hibernate. So I have started the command line systemctl hibernate. It took around 30 seconds to hibernate everything correctly. The computer stopped consuming electricity power. The LED on the power button has turned off. Then if I have touched a key on the keyboard, it shows the screen wakes up for a number of seconds, shows the battery status, but then the screen turns off again. So I'm going to guess that that's a feature from the firmware that doesn't actually restore the hibernation state. It just the firmware, the UEFI, has these code paths where if you touch a keyboard key, it shows on the monitor information for a number of seconds. But then the hibernation state was on at all of these moments. So I needed to actually press the power button to resume from hibernate. But then, unfortunately, something is configured incorrectly, either in the bootloader, probably grub, GNU, grub, or in systemd, or in Ubuntu somewhere, I know, in the initramfs. So the promise that if you have enough partition space, hibernation should just work did not live up. So we'll need to perform probably additional steps. We're going to need to edit the command line parameter at least in two places. Resume to say the device, so /dev/where the slash is, because that's where the /swap file is, And then we also need to specify the swap file offset. So let's see how we do that. Let's become super user. lsblk-f. Okay, so we're after slash, which has this global unique ID. So the command line parameter is going to be like this probably. Resume equals and then UUID and then equals the global unique ID that we have just seen. And then we also want the swap file offset. Let's see how we do that. So file frag space -v and then /swap file. Okay, and we need to look at the fourth column here. So not ext, not logical offset, But physical offset, the first one, this one. Okay, we need another Linux kernel command line parameter. Resume underscore offset equals. And then we want the first large number in the column physical offset without the trailing two dots. Like this. Let's check again. So resume underscore offset equals this thing, which is this thing. And then resume equals UUID. And then we have the UID as a persistent block device name. Let's edit the kernel command line /etc/defaults/grub. We're going to use the built-in command line text editor because we want to run the editor at the command line where we're already the user root. We need to look for the line where it says grub underscore cmd line underscore linux underscore default. And at the very end of this, before the final single quote, we're going to just paste. Okay, so previously there was single quote quiet space splash single quote, and now it's single quote quiet space splash space, and then what we pasted. Resume equals UUID equals the global unique ID space, resume underscore offset equals the number that we got from file frag. Control X to exit, Y to save, press enter. Since we have edited the grub configuration, we're going to need to update grub. Okay, so this has written the correct files in the current instance of grub, which uses UEFI. Next up, we're going to reboot. Okay, so we have enlarged the swap file /swap file. We have edited the Linux kernel command line. Let's check that that's the case. How do we do that? Proc cmd line. And indeed, the currently running Linux kernel uses the correct command line. At this point, I have started an extra application just to make sure that when we restore resume from hibernate, the exact same applications are presented on the desktop. So we have a system monitor and then a console. At this point, I'm going to actually try to hibernate. So systemctl hibernate. So everything was successful, both suspending to disk, hibernate, and also restore. Suspending took around 12 seconds. When it has finished suspending, I have resumed the computer by pressing the power button on the laptop. When KDE Plasma has started, or Plymouth, I could see that it said resuming from, and then it provided the path to the disk. So that's a encouragement. I can feel that it's actually resuming from hibernate, not the hibernation was successful, but then resume could not be performed, and then it just does a cold start of the computer. Also, the KDE Plasma session looks exactly as I left it. And then I wasn't presented with the desktop manager to select a user and password and then to start the KDE Plasma session. Instead, I was presented with the KDE Plasma lock screen. So the resume was just correctly. Everything just worked. Again, I'm a bit intrigued why there's documentation in various places where it says that systemd plus UEFI is enough to store the resume UID and resume offset automatically correctly in UEFI variables, but then that doesn't work for me. And this feature is advertised for at least 2 years, and we're in the year 2026, and I would totally expect that Ubuntu plus systemd have this feature perfected and working correctly. If I increase the hibernation, the swap file size, hibernation should just work out of the box. I see 0 reasons not to have this final bit enabled by default. I know, use UEFI variables, write a file on disk, edit grub, do whatever you do, but don't force people to edit their command line parameters to add the resume and resume offset parameters. The systemd, the kernel userland, the kernel mode knows exactly that there's just one swap location and it's a file, knows how to compute its resume offset, its disk. So all of these things are known perfectly to the system at the moment when I hibernate. So why is this step still needed? It's just puzzling to me. Yeah, if you have UEFI with secure boot enabled and hibernate will just refuse, that's a use case, that's a user scenario. We're not in that scenario. Everything's just perfectly aligned. The hardware is well supported. I don't have any NVIDIA hardware in here. We're in the best scenario for the slash partition file system. We're using ext4, not BTRFS. So it just puzzles me why people don't configure Ubuntu correctly such that this thing works correctly. It just looks like an incomplete configuration or maybe a missing feature in systemd. But other than that, if you follow all of the steps, so you install Ubuntu as per its defaults, which means /ext4 file system /, and then a swap file, not a swap partition. You increase the size of the swap file to be larger than the random access memory. And then you follow the final part, which is editing the Linux kernel command line, restart, such that the command line parameters for the Linux kernel are applied, and then systemctl space hibernate should just work correctly. So this was it. Fortunately for me, hibernation works correctly in Ubuntu 26.04 on this recent laptop. Thank you.